consider a case where our body is projected with a velocity of 20 root 2 meter per second at an angle of 45 degree with the horizontal, and it goes like this. We are interested in finding its net velocity and displacement at t is equal to say 3 seconds. So what is its net velocity and net displacement at t is equal to 3 seconds? If we take this as y-axis and if we take this as x-axis, so this is x, y and this is origin, we are interested in finding its net velocity as well as the net displacement t is equal to 3 seconds. If we say what is the net velocity at t is equal to 3 seconds, it doesn't mean we are just bothered about what is the velocity along the y-axis or what is the velocity along the x-axis at t is equal to 3 seconds, but we are interested in finding the net velocity, which is a resultant of velocity in the x-axis and as well as velocity in the y-axis. We also understand that is in this case ax, that is acceleration on x-axis is equal to 0, acceleration along y-axis is g in the downward direction, and all the vectors in the upward direction we are taking as positive, in the downward direction we are taking it as negative. This way we can take it as positive, this way we can take it as negative. So first is, let's find what is the velocity at t is equal to 3 seconds, that is what is the velocity vector at t is equal to 3 seconds. Let's say at t is equal to 3 seconds the body is over here, so its velocity is in this direction, so this is the net velocity vector in this direction. It has two components, one is the velocity along x-axis, the other is velocity along y-axis. So this is vx component, this is vy component. And what is the net velocity? If this is vx component and if this is vy component, we say this is vx component, this is vy component. So net velocity vector, if we are interested, its magnitude will be the velocity vector, net velocity vector magnitude is going to be the magnitude of vx its whole square plus magnitude of vy its whole square. So this is going to be magnitude, and theta also we can find out, that is tan theta in this right angle triangle. If this is vy, so this is also going to be vy only. So perpendicular base, that is vy by vx, so we can find the angle also, we can find the magnitude also. So now let's find what is the value of vx and vy over here. This is 20 root 2 meter per second. We can break in two components. It is 20 root 2 cos 45 and this is 20 root 2 sin 45. It is only for the ease of calculation we are taking such values, that is 20 root 2 and over here 45 degree. It could be anything. You can take it as 15 degree, you can take it 30 degree, 60 degree, any value you can take it. But right now our emphasis is more on the understanding the concepts rather than getting into the calculations. So this component, it comes out 20 root 2 cos 45 and this component comes out to be 20 root 2 sin 45, because this velocity is given as 20 root 2 meter per second. So cos component, sin component. So cos 45 is 1 by root 2, so 1 by root 2, so this comes to 20 meter per second. And similarly, this vertical component, initial velocity along the y-axis, comes out 20 meter per second, and we say this goes off because now this vector has been represented by its components. This velocity is responsible for taking the body, moving the body along the x-axis, and this velocity is responsible for moving the body along the y-axis. So if we say Vx is equal to ux plus ax into t, ax is equal to 0, so velocity along the x-axis all the time is going to be 20 meter per second only. So this is going to be 20 meter per second here also, all the time. What about Vy? Let's say Vy is equal to uy plus ayt. We are finding at 3 seconds. So this is uy. Uy is what? Initial velocity along y-axis. We have started our observation at O, and let's say we are closing our observation at A. So O to A we are talking about. O is the initial point of observation. So Vy is equal to uy over here, that is 20 meter per second. It is in the upward direction. Upward direction means positive. Plus ay. Acceleration on the y-axis we are taking as g in the downward direction, and the downward direction is negative, and for the ease of calculation we are taking g as not as 9.81 meter per second square but 10 meter per second square. So this is minus 10. Time we are taking from here to here is 3 seconds. So Vy comes out to be 20 minus 30, that is minus 10 meter per second. It means right now when the body is over here at t is equal to 3 seconds, it is going to have a velocity of magnitude 10 meter per second and in the vertical downward direction. So now if we use this to find the net velocity, So net velocity is going to be under root Vx square plus Vy square. What is Vx? Vx is 20 meter per second square only. So it is 20 square plus this is, you can put it minus 10 or 10, anything, it doesn't matter. So it is going to be 400 plus 100 is going to be equal to root 500 is equal to 10 root 5 meter per second. This is the magnitude of this velocity. And what is the direction, that is how much angle it is making with the x-axis. So tan theta, over here also we have done it, Vy by Vx. What is Vy? So this is right angle triangle. We are not bothered about plus or minus. We are just bothered about what is the length of this. So Vy is 10, this is 10, perpendicular is 10, base in this right angle triangle is, this is 20. So theta is equal to tan inverse 1 by 2. So over here we have found the magnitude also, we have found the angle also, that is direction also. This way we can find the net velocity. Similarly, we can approach to find the net displacement at t is equal to 3 seconds. At t is equal to 3 seconds, when the body is over here, now let's remove it. Its job is done. It is over here. So this is going to the net displacement. This is going to be net displacement. What is this? This is, if we say this is Sx and this is Sy. Sx is in this direction, this is Sy is in this direction. So now, if we are to find what is this net displacement, S net, its magnitude is going to be Sx square, that is magnitude of this displacement square plus magnitude of this displacement square, because this is a right angle triangle. Sx we can find out, that is at t is equal to 3, Sx is equal to uxt plus half axt square. Ax is equal to 0, so Sx is equal to ux into t. Ux is what, 20. Time we are taking at 3, so this is 60 meters. So from here to here, it is 60 meter. From here to here, the body has taken t is equal to 3 seconds. At 3 seconds, the body is here. And in these 3 seconds, the body has moved 60 meter in the forward direction. Now we are interested what is the displacement along the y-axis. So we say uyt plus half ayt square. S is equal to ut plus half at square. Along the y-axis, we say sy is equal to uyt plus half ayt square. Uy, once again, we are starting our observation at O and closing the observation at A. So our journey is from O to A. Uy over here along the y-axis, it is 20 in the upward direction, so that's why it is positive only. Time is 3 plus half. Acceleration along y-axis, g the downward direction, so it is minus 10 into time square, 3 square. So this 20 into 3 is 60. This comes out to be minus 45. So this comes out to be 15 meter. So Sy is 15 meter, it is positive, it means it is above this level. So this comes out to be 15 meter. In this right angle triangle, this is 15 meter and this is 60 meter, and we are interested in finding this length. Let's say O to A, we are interested in this length. This length or this hypotenuse of this right angle triangle, that is, if we call it as S magnitude, is going to be equal to 15 square plus 60 square. And if we have to find the angle also, theta, that is in this right angle triangle, tan theta is equal to perpendicular base, that is 15 by 60, or theta is equal to tan inverse 1 by 4. This is the angle also. So we have found both the things. We have found the magnitude of this vector also, and we have found the angle of this vector also. And if required, we can also represent this vector in the usual vector notation comprising I cap, j cap and k cap also.